It's the SDG Podcast. Before we get started, you can check us out on the web at solutiondesign.com/podcast or find us on all the social medias, LinkedIn, Twitter, Facebook, and Instagram at Solution Design Group. All right. Another podcast. Let's go around the horn. Say hello and introduce yourselves, podcasters.
Hi, I'm Peter Lawrence.
Hi, I'm Ben Verhey.
All right. And I'm Kyle Bacher, and today we're talking about going from business data to business intelligence. So what does that journey look like, gathering up all that data and turning it into something meaningful that will help you make decisions and be awesome? And so that's why Bennett's here, because he's our data guy. So he'll be doing all the talking.
To be awesome. That sounds pretty open there.
It's a tall order.
Yeah, that's a pretty big order.
Yeah.
Well, I think the bigger your organization is, the more distance there is between like people and what's going on the front end, in the trenches and that kind of stuff. So you rely on your measurements, your data. Plus, you want to make decisions with data anyway, because you're dealing with reality then, how things are, not how you're perceiving things. So, but you can lie with data, right, Bennett?
Very easily, and sometimes without knowing so. Yes.
All right. So the first step, I guess, if you went into a place and they don't have any dashboards or metrics or anything like that, they just are running their business and filling out fields, and they're gathering all these things, but they haven't done anything with them, what would your first kind of step be?
Sure. I think there's two things you could do. You mentioned KPIs. One thing, just some standard, like run-of-the-mill, suggest some things, right? Hey, other companies do A, B, and C all the time. Have you thought about doing A, B, and C? There's a reason you're paying to save the data somewhere, whether that's a text file, Excel spreadsheet, in some database, in the cloud, wherever, right? You're paying for it to be there somehow, some way. Whether that's cheap or expensive, you're paying for it. So let's do some KPIs, figure some things out, just some standard generic thing. Let's check the small boxes first, right? And then after that, the second thing would be, what are your problems? Typically, consultants get brought in because a couple of reasons. There's a problem to be solved that company doesn't know how to solve. Maybe staff aug, or maybe just working on a project, or maybe firefighting. So typically they might have some idea as to what they're looking for or what's going wrong, and they know what they need to fix, or they know what they want to build. So that'd be part two. They already know that they need these other metrics. They just don't know how to go get stuff, or they want this data to go from A to B so that they can do those A, B, and C KPIs. So those would be like the two standard things I would say that you'd walk into as a data consultant for turning data into intelligence.
And so that's going to inform like where you need to find that data, and then throughout the process, you're going to have to make it accessible. It's going to have to be in some kind of database. It can't you're not going to grab it from every spreadsheet and old
Right.
Access database or whatever. I mean, you're going to have to get it somewhere to work with it.
Yeah, there's more places than you know that probably have their data in an Excel spreadsheet. Somebody goes in once a month, does some things, crunches some numbers, and says, voila, we have the numbers for this month, right? That could be multiple departments do it that way, multiple sections within a department do it that way, and they might come up with different numbers. And so you have there's kind of the worst case scenario thing that happens. I've seen it happen several times where different people bring their numbers and they all have the different numbers to try to prove the same thing, and you get higher ups in the meeting, and this group of people says, this thing is purple, and another group says, no, it's 30 cents, and another group says something else, and you're just like, this isn't this isn't working. So yeah, there's some standardization. Let's bring it all together. Let's put it somewhere. Let's agree upon certain standards, and let's get it out of those Excel spreadsheets if that's the what needs to happen, so that everybody doesn't have their own copy and manipulates it differently. It's not all in different Access databases. It's not all just sitting out, in some random person's head where they've always done it for the last 20 years and hopefully they don't win the lottery. Things like that. Yeah. So let's get it all in one place. Or standardized places where we can start to do some work with it. We can start to glean some value out of it, and not have arguments in the monthly decision making process.
And then that really opens up the door for other uses for that data as well, because it becomes more accessible.
Yeah.
So if Peter's got to build an application, he can tap into it with his app.
So speaking of that, don't a lot of these spreadsheets come from similar sources? Did you guys talk about that? Where does all the spreadsheet data come from? Are people just making up numbers on the fly, or?
So I have seen it where we'll just say a sales manager has been collecting data on people that they work with, and they're keeping month over month stats that maybe the database isn't keeping data that way, right? Where the database is just saying, hey, so-and-so sold, 10 units this month, or that's how many they've sold total, and it doesn't show you the month over month. So that maybe there's some processes there that aren't being taken into account that person is doing in their spreadsheet, but it could be automated, save them a bunch of time, and they don't have to work this all out, and they don't have to teach the next person in line all of their secret sauce.
Right.
It's programmable, right? Like you can do this. And a computer can add and subtract month over month kind of things. So yeah, I guess that would be a use case where somebody might be doing something slightly different. They may be pulling it out of a database, another spreadsheet, an application of some kind, but they have their secret sauce and they just haven't communicated that to be automated.
Right.
So Peter, were you thinking about validation?
Well, validation, or, a big thing is sometimes 3 different people come with 3 different spreadsheets that base themselves on the same data. They're just mixing and matching it differently to come up with numbers that they want to see. And, if they come in and say our sales are doing great, and somebody else says our sales are doing poorly, you have to reconcile those 2 different angles, and they've got to be using the same data because everybody knows how many sales have happened, right?
So it sounds like possibly changing the way they're getting that data in the system then.
Well, and taking those spreadsheets and starting to build out that actual data report or whatever you want to talk about, right? That's, to me, Bennett, you mentioned some of the check boxes, the early check boxes that you want to do, and that seems like one of the easiest ones to target it, right? Is to get a consistent representation of the data across the whole company, or at least the organization that you're dealing with, right?
But maybe you need to go collect all of those. Maybe you need to talk to the marketing department and accounting, right. and there's all these different pieces of the puzzle that are spread out across the organization, and you got to go talk to those individuals, figure out who's the person that kind of knows where things are at, figure things out, figure out what 4 applications they use, and then pull that data together to then create that overarching picture that you would present in that Excel spreadsheet. And you need to get all of that for the 4 different spreadsheets that are presented that have different numbers. You need to go figure out where all of that data is coming from and
Right.
make this unified picture come together.
What if they don't have data? What if they just
Everybody has some data, but if that's the concern, then maybe it's a and maybe I didn't let you finish your question, but I would say you could start collecting data today. It's
I
really
mean,
easy. Everybody does it now.
everybody collects some data, right? I mean, certainly
Yeah.
you have to do some bookkeeping and things like that, and pay taxes and not overpay taxes and all of that. But sometimes that might, if the business is just getting started, that might be where they're at, right? They're just doing basic stuff and not gathering data like they should be.
Yeah, and I think that one of the points that we might have wanted to talk about was to what scale do you want to or need to collect data, right? So
Right.
if you're just starting out, maybe you're a mom and pop shop, maybe you're out of your garage working on stuff, you probably don't need an enterprise level data collection system, right?
Yeah.
Your Excel spreadsheet's probably going to be way more powerful than you need. It's not worth the cost of this enterprise giant thing. But maybe now you're moving out of the mom and pop shop and you're moving up and now you're maybe in one of those Access databases from old, which aren't they're still working. Or maybe you're jumping into a relational database, something like SQL Server or Oracle, and maybe you've moved up and started doing some data's coming in. Maybe you just need to clean up email addresses, right? You just want to make sure that you're not sending your customers 30 emails a day. Maybe just once a month would be better, so you can kind of keep track of that, right? So there's data there. Moving up, maybe we start to get into, we have this larger amount of data and we want to get into a data warehouse, or maybe we've moved away from that now and we're moving into data lakes, because data's coming, unstructured data, semi-structured and structured data is all coming in. Maybe you're getting text messages from another company. Maybe you're getting pictures sent to you by customers. Kind of think about like Amazon, right? When you get an order or it's shipped to your house, sometimes you get a picture of that. Well, that's not like structured data, that's a picture, but it's tied in with your order, the price of your order,
Right.
when you placed it, where it came from, et cetera, right? So now we need a place to store all this data that relates, but it's not necessarily a digit per se to store as a number. And then it just keeps going up from there, right? We're moving into large corporations now where I, as a data person, can't just walk in and say, we need to do these 3 or 4 different 5 KPIs, right? Now it's this huge thing where I don't, or maybe haven't come across this data set before, which is often the case with large companies where they're looking at something very specific, and I don't have experience with that. So I need to work with somebody that is knowledgeable about the domain and knows that data, knows where it's coming from, and then I can work with them and we can pair and figure out how to make that data worthwhile, because it is. We just need to get there and then add value to the company, add value to decision making. Really, that's what comes down to. It is making decisions, whether those decisions are automated or taken by a person. We need to make sure that those decisions are better informed and that data is helping drive that decision so that we can make the right decision in a timely manner. And that's kind of the end goal to some degree. Even machine learning, we get up to that, like large data sets, right? What is machine learning? Machine learning is pattern recognition at a level a human, even super smart humans, can't do, because computers are great at crunching numbers. And I can't even memorize, I think I said before, like a deck of cards. I don't know, like 10 cards. I don't know if I could memorize the order. Just, snap your fingers. I can't memorize that. But a computer can go, I got 10 million cards and I know the order of all, and it can see these patterns. And so we can build pattern recognition. And that's how we get some of these prediction. They're not true prediction. It's just based on past history. We think this is what it'll be like. And so we're making better decisions still. And that's just, that step pattern just keeps getting further along, and we're doing more with our data because there's more data. So
yeah, I know you talked about data lake, and I've heard the term data swamp.
Yeah.
So is like, I've gathered a whole bunch of data and I've determined nothing meaningful from it, right?
That can be. Yeah, so if we're creating a lake and we're not putting good things into the lake, we're not keeping the water clean, we're not actively working on trying to, make this thing work, yeah, you're going to end up with a data swamp where there's cattails and green algae, and it's so data is the same way, right? So other than compared to other technical aspects of things. Data is a physical, tangible, maybe not tangible, but it's an asset, right? You can't just wipe it away and start over. They're not going
Right.
to do that with your bank account, right? They want to know
I
how
hope
much
not.
you have in there, or how much you owe them, depending on the account type, right? And
Right.
so they're not just going to go, you know what? We're going to come out with a version 2. They're not just going to wipe all of that out and start over. So data lives on. And so in a swamp, data lives on, and it can get stale. Maybe it's not up to date information, and you need to go get a new set. Maybe there's just so much of it, you can't find the meaningful data in this gigantic mess of things. So having it organized, structured, understood, cataloged, however you want to go about that. There's some methodologies to do that well, but it needs to be structured to a degree. And structured is maybe an overloaded term in this case, but it needs to be well thought out and placed in a organized manner so that you can actually go forward and use it later down the road.
So before I start capturing data, I need to do a little bit of thinking about what I'm capturing it for, not just, oh, wouldn't it be great if I knew what, Kyle bought back in 1995 from this store on this day. Well, Kyle from 95 might not care about that product
Right.
anymore at all, right?
He might not, or maybe he really does still. We don't know, and that would be something to go find out. So we have to figure out what Kyle wants from 95. But I think what has led to the data swamp, and if things have gotten that bad, is how cheap it is to store data now. How there's really no
That's
excuse
true.
anymore about, so back when I started, which doesn't seem like that long ago, and maybe it's not, but like we would optimize things like, do we want to store this data because it's going to cost us money?
Oh, you
Well, it'd
would
be
go
handy.
down to the field name level, like
Yeah,
you didn't want any fat anywhere
yeah,
because every little character mattered because storage was so expensive.
and you didn't want to run out because things were on prem, and you wanted to, like, if you ran out of data storage capability, your database server would just choke and you're done until you wipe some stuff off. You go in, manually clean it out, and you're down during that time, right? So your company is losing money. Nowadays, you go to Amazon S3 and you can just go, I want to select the intelligent tier, and it'll go, all right, if your data is more than, I think it's 45 days old, we're going to drop it out of the hot, and we're going to drop it to hot cold, or there's different names for it, and then all the way down to glacier, and it's going to automate, it's over 180 days old, or over 90 days old. It's going to drop it tiers and save you money automatically. You don't have to touch, it's just going to do that.
Right.
You just got to check the box to say, yeah, I want to be smart with my money. That's all you got to do, and it's infinitely scalable, so there's not any limitation. So that's how we get to the data swamp. Is it's so cheap now to store it. That didn't, it was the inverse problem before.
Whoever came up with the name Glacier for that slow to retrieve, long-term storage, whatever, it was a genius.
Well, they were, but now glaciers have taken on a whole new meaning, right? Now they're melting and stuff. But no, back, a classic example that I always think about because I'm really old is, Y2K, right? The whole reason that we had that problem was because storage was expensive. And so you only stored 2 digits of the year, because why would you ever need more than that?
No, it's not going to last that long. We're not going to run these systems for as long as we absolutely can before we spend another dime. I have so many generators, Y2K, 2012. I just keep buying them. Generators and toilet paper. So do you need to come at it both ways in terms of what data we're gathering versus what numbers we want to see on our dashboard?
Yeah. So as a consultant, I think it's easier to stop and the start at the top down level, because typically, again, the client will know, this is our problem. Can you help us solve this problem? Right. And typically that's a top down approach. There's not too many cases as a consultant where you're going to start bottom up. Now, as an FTE at a location, you might take a look at the database and go, wow, we're storing all this data. Look at all that, like we could do some cool things with this. And that's kind of that bottom up approach where you discover accidentally, maybe, we are storing all of these things. Maybe we really do know what Kyle bought back in 95. And now we can create this cool machine learning algorithm and predict what kind of toilet paper or what kind of generator he wants to buy in 2025 and start advertising to him that way. So yeah, as a consultant, top down typically is the method, just because of circumstances, and FTE could go either direction, I think. But yeah.
So consultant gets told, I want this answer. This is the answer. Or this is the piece of data I'm looking for. And then, but I don't know how to get it here. And I've got this whole area that I'm pretty sure has the data in it, but I'm not sure how we stored it. So go find it.
Yeah, go find it. Yeah. I mean, there is sometimes where it's like, hey, we want to do these things, with going forward, and then you have to go find, okay, how can I support this? And maybe that presents the case of bottom up, where I'm going to go look for certain things so that I can build this thing to support what a client wants. So that might be a bottom up approach, but I don't know if that happens as often.
So once you start peeling back those layers and seeing what's actually been gathered in what formats, and like how much do you surprise the people that want the magic numbers with like what that work entails of actually making all that happen?
Sure. Well, tools have definitely gotten better. Visibility has gotten better over the years. The ease of use of some of the tools has gotten better. So a client would have to support what you build if you're not going to stick around indefinitely. So I think that's an easier answer nowadays than it used to be. So I don't know if there's any large surprises. And typically, if they're storing data in a very strange, weird, obscure way, they probably, hopefully, already know that and understand that to get that value add out of this wonky system, it's going to take a little bit. So there's a little bit of give and take there, I would say. But things are getting easier. Tools are getting better. The data revolution is really, the last 10-ish years have really seen this awesome growth in tools in the data industry, and with the advent of cloud really starting, in that same time frame, the cheapness of how to store data and how to process data, that has gone so much towards making things easier as well. And in the cloud, we're also, I think the biggest revolution that happened not too long ago is the ability to split and scale independently. 1, where you store data, compared to 2, where you process data. The splitting of that atom really made things scalable and changed the dynamic, because before you would have data stored on site in a SAN on a server somewhere, and that server had a ton of RAM, and those two things were married. But now we've split that apart, and that's really what's made this go crazy in the last few years here. So you're looking like something big in the data world, Snowflake, right? That has the ability that separates those two things, keeps those separate on whatever cloud you want to use it on. So I think that's really been, tools have made things a lot easier, cheaper, better, faster. So I think that conversation's pretty easy to have these days.
Well, and the cloud has really changed that data dynamic. In the ancient times of 10 or 15 years ago, where that SQL server might be such a cornerstone for the whole business that nobody wants to touch it, nobody wants to change it, or we only do things to make it go faster. We'll put more RAM into it. There's a reason why server manufacturers up the maximum amount of RAM, and it wasn't for Doom servers or anything like that. It was more for SQL servers just chewing away, right?
Yeah, that's a good point. And a lot of times that procurement process to I remember one time when we were getting a new server, and it took months from the
Right.
time we said we want it to getting approval for because it's a huge upfront capital investment, right?
Right.
Yeah.
To the time it shipped and was put together, and by the time it had SQL installed and somebody paid the horrible licensing fee. I mean, there's a joke around that. Anyway, by the time you had that
a shocking to most people licensing fee that's based on processors and not based on a box, right?
Right. Yeah, it could be very expensive, and it typically was, but there's so much you could do with it. But by the time that was up and running, and you had that, it had been months in the making, and technology had already evolved. New processors came online, and etc. And now you can do it as code like Terraform or something like that. You can just, I want a new database, click deploy new database, right?
Done.
Or even just go into the UI in a cloud provider and click new database, give it a name, click build. You got one. How big do you want it? Oh, I want to make it bigger. I want to make it smaller. You couldn't do that before. You were stuck with that giant server. And there was only one. And to your point too, you can only make this thing faster. So what if you wanted to test something, but you need that amount of RAM to test it? Well, now we're going to test it on the prod server off on the side, right, at midnight. And hopefully that doesn't break anything. And the cost to get a test environment or a QA or UAT or whatever environment you want to set up that's equivalent to prod just wasn't in the books, wasn't going to happen because nobody was going to sign that check.
Nobody was building 2 times prod, right? They would build 1 prod because it was so expensive, but never 2.
Yeah. So the advent of the cloud, just you can iterate so much faster on new things.
So what step, I guess that step is part of, like, what are we gonna, like, how do we normalize? And once you've figured out where all the data is, like, then you need to get it to whatever platform that is, and that work of, what is it called, ETL and all of that, to get it into your lake, your data puddle, your swamp, your boathouse, whatever your warehouse, figuring all that out, knowing what kind of, because I've looked through the list of stuff in AWS and Azure, and there's a lot of options out there.
Yeah. There's a lot of good options. That's the better thing.
And it's funny because those options, didn't even exist 5-10 years ago, right? There's just been an explosion, and you can see the difference the cloud has made, and in that one space has just changed the game completely.
Yeah, and going back to that separation between processing power and storage power, another cool thing. So Kyle, you mentioned ETL, right? So extract, transform, load. And that's evolved a little bit too as of the last, in this last decade, where, so ETL, extract, transform, load, we used to do that, but that would marry your tool that you're doing this with to your source and your destination to a degree, because only this tool was built out. You have all this logic built in there, right? So I'll pick on Snowflake. There's more than Snowflake, but I'll pick on Snowflake again. So what you can do now is ELT. So you switch those last 2 letters, right? So you extract and you load exactly the same into your computational system. And then once you get it there, then you can do all the transformations, right? So now you're only pulling net new, net changes, net deletes into your system. So it's a very small transactional value. You're not doing huge computational values on the fly as you're pulling it in. And once you get it into a Snowflake or an equivalent, or a data lake, or however you want to do it, right? You get it there, and then you start to transform it. But everybody can have access, or might have access, depending on security permissions and all that. You can have access to the source system data, and you can query it, and you're not bothering the source system anymore. You're not bothering prod, that big prod server anymore. You're not monkeying with it. You got a copy of that data sitting there that you can play with in your own way, and you're not going to mess anything up. And you can do transactions. Oh, we're adding this thing incorrectly. We're calculating that wrong. Let's tweak the system. Boom. all that processing power is right there. It can scale, and we never messed with that prod environment thing that we are pulling the data from.
Yeah,
And then, oh, sorry, go ahead.
I was going to say that's another good point, because even, recently you wouldn't think of, oh, I'll just spin up a read copy of my prod database that gets, updated super periodically and stays almost in sync.
Well, you wouldn't. You might do that for a special one-off case or like a proof of concept, but not to have it it's still working. And maybe we'd only be pulling that example I gave. Maybe we'd only be pulling that data once a day, maybe every couple of hours or something along those lines, just so that we don't fall too far behind. But there's another pattern here too. As we kind of move up this chain, like a lot of things now, again, due to the advent of the cloud, we're seeing a lot more event-based items. Instead of, every hour or so I'm going to pull data, every time there's an event that happens, I'm going to get that. And it's going to be pushed to me. I don't have to go get the data. Somebody's sending me the data, right? And every time something comes through, and it's these small transactional bytes, it's easier to take in, it's easier to process. And we're going to get those. So now we're in this event-based environment. So we're going to get the data, and then we're going to, oh, hey, data came in. Let's process quick. And we're going to tweak the things that need to be tweaked and leave everything else lie and not need the. So we're getting smarter, because say we aggregate every week, right? Maybe we could aggregate just this week, and we don't need to aggregate the entire 15 years back to 90 or however far back, 95. Man, 95 is a long ways back now. We don't need to aggregate every week all the way back to 95. We can just do this week's, and we save time, we save computational, we save money. There's so many cool things you can do now where we're getting smarter, and that means faster, cheaper, better.
Yeah, because I mean, if you're not going to just have a scheduled thing that happens, usually that's when there's no trigger. Like, it doesn't know when to go do it. So you just say, we'll do it every Sunday.
Yeah.
And then it's going to go run that, because that's how there's certain things I have that run like weekly to keep things synchronized between systems. But really, they'd only have to run if something changed like if somebody's title changes.
Sure.
That's a one-time, like, but you have to have something that notices that to trigger it to do it. So like the tools are way better now for doing that.
Right.
And that's another to like cost savings. Instead of doing it, running this process, using processing power and moving data around every week, if we don't need to, why do it? We're just wasting horsepower.
So through the process, like if you set out to do, like, we want better metrics, we want KPIs, we want a dashboard so we can make the big decisions. But through that whole process, you might find ways of saving money by the way you're handling your data, by the way people are inputting things into the system, like your capture process. Like, do you find that happens frequently?
Yeah. And yes, 100%. That happens quite often. It's not everywhere or every place, but it does happen very frequently. I've seen it, even just changing how code is written sometimes. And again, a lot of these things I've been talking about, I'm generifying them or making them super generic. But yes, even if you can change the way code is written, sometimes how data is handled or processed. There's different ways of writing a query or writing Python code or doing this or that to make it way more efficient. Instead of, say you have a table that has 1 million records and you need to update column whatever to a new value, but it's across the board. You don't just update one row at a time. You just say, update them all right now, and they're done. So, that kind of difference of code where it's like iterating over it versus just updating the column all at once. That's a huge time saver. It's going to save on if it's a locked kind of table, like a relational database, you get one lock, it's done, and you don't have to keep getting locks and keep releasing them. There's not a churn on the data set. It's just done. Depending on how the data is stored, if it's a row or columnar storage, it's just done so much faster. There's so many things you can do, like in Python, vectorizing your code versus leaving it doing that row by row kind of aspect. As far as data interaction, there's a lot of options on how you do it, when you do certain things that you can make it a lot more efficient. And doing that can save you real dollars. How long something takes to process in the cloud or on your own machine, or you're either competing with other resources or you're saving money in the cloud. So yeah, I think that's a fair point.
So Peter, when you're developing stuff, applications, how tightly do you have to work with the Bennett at the organization, the data people, while you're putting your code together?
Most of the time, really tightly with them. A lot of things have, progressed forward and backward and all around as the database admin title has rolled and changed over time. Sometimes I'm doing database development, as part of my project, because I now have a tiny little piece of database that I get to work on. And so nobody cares because it's just mine. It's for my program. My microservice has its own copy of the database, the pieces that it needs, and I get to choose what I do with that and then spit it out to everybody else as we go. So, architectures have changed quite a bit. It used to be like, oh, Mr. DBA, please write me a query to get me this data that I need for this display. And that those days have gone quite a while ago, which is good, right? It tends to decentralization helps speed up a lot of things, and that's one of the things, right? You don't have to wait for data changes, or you just ask somebody for, like, I need this data, where do I get it? And they'll be like, it's here, it's in this report, this data lake, this lake house, or whatever you want to call it. All of those kinds of things that we've talked about in the podcast before. Just you get your data and you do things with it, and it's awesome.
So Bennett, how do you prevent accidental deception when you're building dashboards, KPIs? You've got all the data, it's all in there and it's all correct. It's normalized. That's all done. Now you have to tie into it and make it meaningful in some kind of chart or graph or whatever it is. How important is it, to know the right way to present that data and format it and all of that?
Sure. I think there's some industry standards in certain aspects, depending on which market you're working inside of. I think a big thing is, again, like pairing with a Peter who's super smart, knows his thing, knows what he's working on. I might not understand the aspects around why the data is stored this way or that way, but I need to understand it. So I need to go say, hey, Peter, can you explain to me X, Y, and Z? Can you share some things with me? Let me see the UI, because that would provide a lot of context. So I need to understand some of those things. I need to understand the domain that I'm working inside of and understand the caveats. So understanding that is key. I think that's the biggest piece of it. And then obviously I myself have to not try to make the data look this way or that way and just be honest with it. Like, this is what it is. Hey, it's a 34. Well, 35 is our threshold. Well, it's a 34. I can't make the data something that somebody higher up wants it to be just because. I have to show, you want the numbers to change. Well, then we need to change the input, not the process, to get it to the KPI, and making sure those gates are protected. And it's not, I'm just going to multiply by 1.2 to get it up to 30, 35, right? I can't do that. That's not ethical. So on my end, I have to be ethical. I have to understand the data and the domain, and I have to present it in such a way that people also aren't going to perceive it as a 35, where I can't put it on a graph where it's really close to 35, but I know it's not 35, but I'm just trying to get it there as best I can. Like, I can't accidentally do that. So there's some things I need to understand as far as how to present data if I'm going to be building the report. A lot of the times I'm just providing the numbers. Myself, I don't build as many as reports. I more so move data and process it. But I do know that's a thing where, I can make it look like it's close to 35 and everybody might be hunky dory and happy with that, but it's not actually 35 and it's actually a super bad number. So how things are perceived needs to be thought about too, as far as when things are presented to an audience. I think those three things are probably the biggest things that need to be done in order to get those KPIs out and understood correctly.
So you don't walk in there and say, well, what do you want it to say?
I mean, they could hire somebody much cheaper to do that for them, to just draw a big 35 on a web page.
Yeah, you don't even need to look at data then, right? You just say 35.
Right. I mean, and that goes back to making good decisions, right? Like if you have already made the decision and you want the data to back you up and there's nothing that anybody can do to change your mind, that's one thing, because I can't help that situation, right? But if we want to know, like, hey, we're thinking about this decision, we could go either way. Which way does the data say? The situation isn't dictating it, but maybe the data could help us pick the better decision. In that situation, I can come and help figure that out as far as processing that data in such a way to help you figure that question to get a good answer.
So now, I remember when I built some dashboards a long time ago, it was pretty much something to look at. They would pull it up, look at the numbers, and then that's what they got.
Yeah.
Now it seems like, I know with like Power BI and things like that, there's all this drill down and things you can do when you get to the dashboard to see the data in different ways.
Yeah.
Is there more of that happening where it's, okay, we're going to give you a dashboard, we're going to give you the data, and then you're going to be able to take that next step on your own to see what is meaningful for your decisions that you have to make versus somebody else?
Sounds like you're describing user enablement, making things powerful for the people that are using them, not just because I might not know what drill downs you want. I might not know you want to look at this data sliced in these 3 different ways. But if the opportunity presents itself where you're granted that ability through a tool, that's super powerful. I think that the data will stand behind it, and we can still go look at the data in its fullness. But yeah, to have those abilities to drill down, that's a wonderful tool for an end user. And I think we're moving in that direction where we are enabling the end user to use those data sets that we've curated to push further into their decision-making process. Maybe they only want to look at this one fine little thing. Maybe it's generators back in 95 and they don't care about anything else. Picking on generators again. That's all they want to look at. That would be a cool, like, hey, filter by category, filter by year, filter by product, boom. Now we can look at just a specific thing where I might, if you think about all the things sold on Amazon, that's a huge, maybe that's a data swamp. I don't know. But there's a huge amount of stuff there that altogether doesn't make any sense. But if you start to look at specific pockets and, in products sold, it might start to make more sense. Certain people might start to stand out and who would be a good fit for, maybe if you like these 3 things, you'd probably like these other 2 as well. And we'll suggest those on your feed for you. Things like that. Yeah.
That's interesting. The Amazon as the data swamp. That's an interesting concept, because there's some products that you go looking for that you do feel like that, and others where you're like, this is exactly what I want.
Well, I know they probably have awesome things built behind the scenes, and I'm more so like some of the products I get recommended, I'm like, I would never buy this, and not that there's just huge amounts of things. There's huge amounts of data behind that ecosystem that drive a powerful machine there. So
that's why I allow all possible cookies and tracking and stuff, because I want to know what I want. 'Cause I figure that if a chair follows me around through all these different sites and emails and whatever, I should probably get that chair.
You like that chair, huh?
It's a good share. It's like, I looked at this one time 5 years ago. Why do you still think this is important to me? So algorithms.
Yeah, so generators plus toilet paper equals chair.
Right. Yeah. So I think algorithm has kind of become a dirty word, because it's like we're not seeing what is there. We're seeing what's there thinks I want to see,
Mhm.
and is showing that to me. It's like I'm getting this filtered view of things based on past behavior,
Mhm.
like, is that fair? Is that the algorithm's fault?
Well, the algorithm, if we're talking about machine learning anyway, the algorithm
Okay.
is just pattern recognition. So there's two ways you can get pattern recognition. One is structured learning, which is where I feed a bunch of data into the algorithm and say, hey, here's 250,000 records, and you get the entire input, and I'm going to give you, out of that 250,000, I'm going to give 200,000 answers as well, but I'm going to hold back 500,000 or 50,000 of the answers.
Right.
So I'm going to train it on those 200,000, and then I'm going to send in that 50,000 after the fact and test it to say, all right, predict what the outcome is in these 50,000 examples. And then I'm going to compare that to the real example. And I'm just going to use that to fine tune and continue to fine tune and get more data in and fine tune this algorithm. So I'm really using an algorithm to build a model, a prediction model. And then that model is what is deployed out to Amazon, the website, to say, oh, these things, you like these things? Well, we've seen in the past hundreds of thousands of people say we've liked these things. And that means you probably like these other things. So
Right.
we're going to speckle them into your feed and see what you click on. And when you click on those, we're going to get more data, and we're going to get better at recommending for the next person that comes along, and the next person. And so it only gets better from the perspective of what is being dropped into your feed or your possible items to add to your cart. So that's structured learning. Then there's unstructured learning, where it's like you just got to go teach yourself, kind of a thing. And as things happen, it just continually gets smarter, and it learns from its mistakes. That's not AI.
So is unstructured learning where you start with 0 records and you keep making random recommendations until they get better?
Correct. Well, you start making recommendations, and if they're horrible, you learn from it. It's kind of, think of it like maybe a good way to think about it is a computer playing itself in chess. Both sides are going to be horrible to start with, and eventually it's going to get better, and it's going to develop sophisticated techniques. It's probably going to do different things. It's going to try different methods at random, and then it's going to start to see those patterns come into view, and then it's just going to fine tune and add more clarity as you go along as it interacts. So there's that kind of machine learning as well, both of which could possibly be applied to what shows up in your algorithm.
So is it are we at the point where, like, when you go through this process with customers of figuring out their data and how to use it, there's tools you can tack on that can look at their data and tell them what additional magic numbers are going to help them make decisions that they may not have even thought about?
That's a hard question. I don't know if
Just say yes.
It took me weeks to come up with it, so.
Yes. No, I mean, I don't know if there's a silver bullet per se on any of that. Again, it falls back to the domain. Like, what workspace are you working within? What are you tracking satellites in the sky and you want to predict where they're going to be, or are you how many trees are going to grow in this certain acreage, or how many widgets are going to be produced by this factory, or those are all very different use cases. And so I don't think that there's a silver bullet that's going to predict all of those in one go. I think that's what we call AI once it crosses the event horizon into it's got its own consciousness per se, or whatever. That's That's like 4 years out. That's not.
Do we
now,
call that
so-
Skynet?
Skynet, yeah. Yeah, I don't know if it's 4 years out or not, but it's. I mean, it's out there a ways, but it's not super far out there. So we're not doing that yet. that
So,
level.
as a parting thought, would it be safe to say that, like this, going through this process and getting all these things in place, is it easier than people think it is now with all these tools and stuff? Like, is there less stopping people from doing it? Is it cheaper than it looks?
It's cheaper than it used to be. It's easier than it used to be. We still have the same. We have to talk to people. We have to figure out what they want. We have to understand what they want, understand why they want it, build it accordingly. So I think getting in the door is easier nowadays. The tools are a lot better. However, there's a lot more tools. There's a lot more options. So picking the right tool for the right job might be a little harder, but at least you have options. So I think it's a mixed bag on that answer. But it'd be pretty easy to step into or starting to step into it. But yeah, Peter, were you going to say something?
I was going to say that you can do a lot more with the same data that you had years ago, but now you have a lot more data and a lot more options. And so,
Yeah.
and the field has grown. I mean, it's exploded lately, right? With AI and other data tools, just amazing tools coming out.
Yeah, and there's a lot more positions too. That's not just the data guy or the DBA.
Right.
There's data scientists, there's data analysts that are analyzing the data. There's we've had DevOps, there's data ops, which is another concept maybe we could talk about later. There's all these, there's data engineer, there's reliability engineers, there's all these different things around big data. There's just so many different smaller niches now that people can dive deeper into. So.
Excellent.
But it all adds value eventually.
And my parting thought is, I think we need to have Bennett back again.
Yeah, my parting thought is data ops. Like this, what is that? I've never heard of it. In 30 seconds, can you just explain it, or do we have to have you back and talk about it?
I'll make you have me back for that one.
There we go.
All right, awesome. Well, I think with that, we should just say goodbye, everybody.
Goodbye, everybody.
Bye, everybody.
Goodbye. Solution Design Group is a digital product consultancy in Minneapolis. Check us out on the web at solutiondesign.com or look for us on Facebook, Twitter, LinkedIn, and Instagram at Solution Design Group.